I'm Alexandra. I'm not sure if we've met before. I am one of the members of the team in Microsoft who are in charge of building the next generation of sovereign clouds. And that's more of a tedious mission than it looks from the description. I'm also coordinating an amazing team of technical program managers who are working day and night in making sure that we can build the systems from a software perspective as well as a hardware perspective. But today we are not going to talk about the hardware itself. We are going to talk about something that, regardless of the areas that I worked in Microsoft, I came across. My career started 14 years ago, and I spent the first 13 years focused on building architectures for data platforms around the globe, working with some of the biggest customers, of course, interesting challenges, and maybe why not working and teaming up with some of you on that road. Regardless if I'm looking at the cloud build-out process, or if I'm looking at the financial institution, or if I'm looking at, let's say, marketing or finance, there's always something that comes to mind. It's data. Data is considered the new gold, actually. We are all making data-driven decisions. Who's working in a data-driven organization? Yeah, a few people, yeah, here and there. Are you working in a data-driven organization? Yeah, okay. What does it actually mean? What's your data strategy? Well, somebody wants to give it a try? Not enough coffee yet? Well, that's a more difficult challenge than you might think, and it's not always just because of lack of coffee. It's because it's very difficult to articulate a data strategy. Starting with 2018, we've seen a lot of investments within the data and AI space. Platforms, transactional data store, data warehouses, data visualization, data governance. These are the key words of the days in every organization. Actually, the investments in terms of focus have increased by 66% if we compare 2018 with 2019. That's just in the data platform space. And we are big analytics, big data, Hadoop clusters, Kafka architecture, everything that's out there. But within the same time, from a business point of view, the results have decreased. The business results, the objectives that we were trying to address were not reached. There was a decrease of 90% in the business results. So we've built all of these amazing platforms. We've focused on the platform. We've focused on the problem. Has it managed to address the challenge? Because most of the times we build these amazing architectures that work as a charm, but are they capable of offering or answering the questions they were built for? So what went wrong? Is it tools? Are we lacking some technology? Are we lacking some tools that we are not aware of? When I started in SQL Server, and I'm going to downplay SQL 7.0 so I don't look that old, I started in SQL 2000. And there weren't many things out there. There was SQL and Oracle and a little bit of MySQL maybe. By 2021, and that's an updated list, please don't zoom in, I promise you won't be able to read everything. That's the updated list of different areas in data and AI space. Technologies available and tools for that. Regardless if it's open source, regardless if it's proprietary, that's what's out there. So I'm going to ask that question again. Are we lacking the tools? I would say no, we don't. I've sat in many conferences in your seats and heard so many conversations about being agile in software development, about building microservices-oriented architectures, about isolating business needs and being able to scale, being able to be resilient, being able to be redundant. And that's great. That works as a charm when we talk about web apps or when we talked about other applications that we develop, when we talk about the front end or back end. But what about data? Why shouldn't data be agile? Most of you and most of the customers, when we talk about data, they have two things in mind, which is where we started from, a centralized platform. I have my transactional data stores, regardless of the technology, which are serving customer needs, where I process banking transactions, where I buy a product, there's a transaction that's created, that's saved in a database, perfect, or a table that gets updated. So the world of data was operational transactional data stores, mission critical, need to respond fast, aligned with asset properties, and the data warehouse itself. No? What do we do with the data? Well, we put it in a data warehouse and everybody builds Power BI report and Excel's. I would say Excel is the most powerful management and reporting tool I still see on the market. So, schema, star schema. Have you heard of star schema? Have you used star schema? Like data warehouses and star schema were best friends, you know? What do? We just add another facts. We just add another facts table. We just add a new dimension to the star schema and we solve the problem. The challenge is machine learning and AI came into the picture. And they're like, good, so now we have to sort of drive some business conclusions out of it. Now we have to analyze trends. We have to calculate risks. You go to the bank, you want to take a loan and somebody needs to calculate the risk for you. So what do? Well, I take these amazing algorithms in ML and AI space and apply them where? On the data warehouse. Data warehouses are still very structured data. You have a well-defined schema. But the world nowadays doesn't need always a well-defined schema. ML and AI, they need semi-structured or unstructured data set to train, to get more context, to get all the dimensions that they need as an input to generate an output. So what do? Well, probably I think it was around 4 years ago or 5 years ago where we had data lake concepts. So data lake concepts was just a sort of a dump area or storage area for all the unstructured and unstructured data. So what's wrong with, and I'm going to come back to this picture. So I'm just going to come back to this picture. So we've sort of tried to take this centralized platform and elongate it a little bit further to the right. Sort of, data warehouse, then maybe I put a data lake in case I have any ML there or AI. And then from the data lake, I'm building some smaller data warehouses. And then finally, I get to my Power BI report. So that's what we want to do, no? We fix the problem. In application development DevOps, does anybody challenge the advantages of DevOps? Nope. Does anybody, does anybody think about DevOps for data and AI? Did you ever think about it as a strategy? What do I do with my data? Connect to my database and run a query. Microservices. Does anybody challenges the applicability of microservices in certain scenarios? No. Of course, there are architectures where monolithic can be better. There are architectures where microservice will be better. But for data world, there is just one, monolithic. So I don't think one problem fixes all, but when we talk about data, you don't think about, well, when should I use the data warehouse and when should I sort of separate it? When should I stop adding facts and dimensions to my star schema and when should I use structured and unstructured data? That's not a question that you have in mind. It's more of, let me see what my company uses as a data store, and I'm just going to crumble more data in there, in that technology. So in the data space, the response to that is actually a concept that transitions from monolithic to distributed decentralized systems, and that's called data mesh. I'm not sure if you heard about it. There's also a great book. It's still quite new in the space, not in terms of principles. The principles were the same as you are using in microservices. The difference is, how does that apply to data? So the top goals is, yeah, we want to have a data-driven organization, great. But organization is composed of many different teams. My organization has tons of teams. Every team works in a very different way. Every time I'm switching from one team to the other, I feel like I'm in a new company. And I've shifted a few. So it's always like we have this thing where we say, this company is like that, or that company is like that. I don't know how others are, but even within Microsoft, you have so many flavors of working. And the same goes with data. But there are a few things that are very important regardless of the area that you are working. And that is security, and that is compliance, and that is data qualification, and that is metadata about data. Because we have so much data that we need catalogs to keep track of data, don't we? We need to know UDB. Probably you heard about UDB. We need to know what's PII data. So now I'm shifting from a problem that I had before, like where is my core banking table and where are the users table, to more of let's approach this from a business perspective. What is confidential data? Is a phone number confidential? Is an email address confidential? And the answer to that is it depends, because you have so many different countries with so many different rules. So now you have to think about it differently and not start from bottoms up, but from top down. There's also business value, because I was thinking about the role of a data engineer. How would I define the responsibilities of a data engineer? I knew how to define a DBA. Yeah, like you have to do backup, you have to do performance troubleshooting, you have to do optimization, install the SQL clusters, install the availability groups, make sure the listener is up, and so on. And I could go on the technical side. But what about the data engineer? Because most of these functions, if you go into clouds, regardless if it's Azure or if it's AWS or GCP, some of these functions are already there. So what should a data engineer do? A data engineer is the person that reduces the lead time from the data to the consumer. Because you do have tables, you do have so many structures and technologies, but the purpose of all of this is to address business needs and to respond to certain questions that we have. And data, you as a data engineer, your responsibility is getting to that response as fast as possible, regardless of the technology that you use behind the scenes. And that's a new concept. We've usually looked at data as a platform. But what we are suggesting is, let's look at data as a product. The same way you look at marketing application or a risk management application within a financial sector. Let's align the data space with that. So, data mesh, is it a paradigm shift? It is, in a sense of, I'm not promoting one solution fits all, regardless if you talk about monolithic versus decentralized, or centralized versus decentralized, or microservices versus monolithics. There will always be scenarios which can serve one and scenarios which can serve the other. But in data, that's a new option, because we didn't have this option before. So in a data mesh, we have actually 4 principles. And those principles are domain-oriented decentralized of data. What in the world is a domain? A domain is a unit, a grouping of a functionality that you have within your company. It can be risk management, it can be loan management, it can be core banking critical application, or it can be a marketing part. So instead of thinking of a single centralized solution that serves all the business units, let's think about data architectures and data solution for each of these domains. And you know what? You can even use different technologies, or you can use the same technology if you want and if it makes sense from a physical layer. But from a visualization, from a process perspective, even from a tools perspective, that can be different for each and every domain. And I would dare to go even one step further and say that, you know what, that can be multi-cloud if you want. And it does sound like a very good option, you know, it's great, but I have a lot of ifs. How do I connect it? Do I have interconnectivity? How do I make sure I don't replicate data? What if in my loan space or loan domain, I need to process data that goes into core banking, for example? Well, that's the principle of data mesh, creating these domains, but connecting them, making sure, and there are so many technologies that you can use, and I'm going to focus on Azure, because that's what I know. When I talk about it, you have data factory, you have data share, you have external references, you have external tables. When I was young, if you had to bring some data from Oracle, like if you needed any data from Oracle or Sybase or DB2, you had to go and think about, how do I export it? Oh my God, I have no native connector. Let me try to export that in a file. Where do I store the file? It has to be in a file share for sure. I'm just gonna give all permissions, making sure that nothing blocks when I reprocess it. And then I'm gonna create an ETL that may pick up that file, may run some stored procedures that I'm gonna run on the data warehouse and process them into the staging space. And from the staging space, I'm gonna have the Power BI and Excel that's gonna have this amazing look. And it takes only 12 or 24 hours. So besides the possible points of failures that you have in this, and trust me, there are so many. Whenever I had an ETL issue, I was like, tell them that I'm sick, tell them that it took me 6 hours just to look like, I was amazed what type of packages people can write, like integration services, or there are so many things, like what you can do there is crazy. It took me like 6 hours to understand what's actually going on. So now you have all of this natively. You have data factory, you configure your pipelines, you have built-in data drivers that connect to multiple services. Most of the competing technologies support and use drivers for all other technologies. You can even create external tables from within your, let's say, SQL to any other technologies, and I'm pretty sure the other way around is valid as well. So there is no need to duplicate data, and connectors are much better than before. A few problems that it solves. It's not a magical solution. It's not a solution that solves all the problems that you've had within that space. And it doesn't really, you still need a central system that's gonna govern the principles of security, compliance, data discovery, and data tagging. So that still has to be in place. It's just a sort of a different approach in how I do it. And I'm gonna come back to this picture. We've talked about where we evolved from, and I'm gonna make a point here on the water pipes. The way we usually look at relational, or not relational, at data stores is more towards like a pipeline mechanism. Water comes from lakes or whatever it's, or rivers, or wherever I can take it from. I have these amazing pipes that put it in a location where I curate it, I treat it chemically, whatever I do, and then I send it to the consumers. to the tabs. So all these Power BI and Excels of the world are actually the tabs. And that's how we usually looked at things before. And we had the lake was, or the operational data stores, all those systems where you couldn't run queries in the middle of the day, because guess what? You were blocking all the insert, update, deletes, and you had to change the isolation model. And if you consume too many resources on that machine, somebody from the core banking system would call you. It's like, what in the world are you doing on our production system? And your access will get denied, and you would never be allowed to run that query again. So those are our lakes. And then this goes through pipelines, which usually is ETL. It goes into a data warehouse where you could do whatever you want. But you had so much data that you were not using. I remember partitioning. I was talking with one of my customers, I think it was from a financial sector, and he's like, he had this huge petabytes database that I was afraid to even touch. And I was like, oh my God, who even looks at this data? I've always like, who spends time? He had a Power BI, no, he had I think it was Excel, a report. It had like 200 pages. You could go for 200 pages. I was like, who reads that? Like, when I get to page 2, I already forgot what was on page 1. I said, no, but we need it. I said, yeah, I got it that you need it, but who reads that? We don't know, but we need it. And there was another thing. They had years of data. And I was like, but if I look at your reports are looking at the last 6 months, maximum 1 year. What do you do with the other 10? Oh, they are there. But why do you need to process them? Because our store procedure was written in a logical way that allows us to process everything every night. And I'm not going to touch that monster. It's so huge, I'm just going to add on top of it. It's like, great, but does it make sense? It works, but does it make sense? And if you have not built a system like that yourselves, because we never do wrong things, like we are perfect all the time, you probably inherited one from your ancestors and from the lucky persons who were there in that space some time ago. So your question is, and another challenge is, how do I show value to the business by just modernizing or re-architecturing something? Because you spent 3 months rebuilding, repumping data, partitioning, regrouping, and you know, when you partition a table, have you tried to repartition a table? Because I would click that button, get in the plane and get back home, and hopefully it would be done by the time I land so the customer does not call me. So it can take a lot of time. And you do a lot of things that are architecturally right and correct, but how do you show the value to the business? And that's where data mesh comes in and says, okay, let's split this into domains, into independent domains, with the same or different data stores per each domain. And let's process that per that domain. Let's use the tools specific to that domain. Let's use the connectors, the drivers, and the technologies specific to that domain. So we have centralized platform that we've started with. We had the core service provider, which was sort of an intermediate architecture that I talked about. So we have the operational data stores. We have the data lake, because guess what? We need all those data scientists to work with some data, so they can't extract value from very structured data. So they need these JSONs and of the world with structured and semi-structured data. And there was a time when we could handle, and we do handle JSONs within the database. That is an option. It's just that it doesn't make sense to apply the ACID principles to this type of data. You are much better off in a NoSQL world with different principles. So if I'm touching the screen and it crashes, just so you know, I probably shouldn't touch it. So that's the data warehouse, that's the data lake that we've evolved to. And from that data lake, yeah, you need to still build your Power BIs, like your manager will still click refresh. So these are the small data warehouses that we've built out of that data lakes. And it's not perfect, and it has some disadvantages in the increased management overhead, and it doesn't really addresses that challenge. Now, there are systems, and you see this in the government space, and sometimes they cannot be avoided, where they have these domains, but they are completely disconnected. Like Ministry of Justice and Ministry of Defense. Like talking to these, even the phone line doesn't work between these two institutions sometimes, you know. They have these highly federated systems, which is a domain. They have a domain for the penitentiary, everything else, but nobody can connect to it. So if I need some data from the outside, it's going to go back to, yeah, you export the data, put it in a file share, from the file share to another file share, it gets into our data center, and from there we're going to process it. What we are proposing, and not us, it's not me, it's the industry, because there is an industry for data as well, is the meshing or the harmonized mesh. In this model, you have the operational data stores that I mentioned earlier, connecting, and you see I divided this through the domains. Core banking will have their small operational data store. Loans will have their operational data store. Some of them may be needed, like user profiles. You're not going to duplicate the data. You're going to have to share it and connect it among themselves. And how can I technically connect it? Well, if we talk about Azure, you have a lot of options there. You have the Azure Data Factories with 3 pages of connectors to third-party technologies and first-party technologies. You have Azure Data Share that does this out of the box. And of course, you need to transform the data, and you can run. Yeah, we have a question.
Just a question.
Sure.
One thing that I'm noticing in the industry is that all the data is app-driven. So there's a certain application, and then it has its own data set. Now the future is extremely easy to interconnect data, but I see nothing done for data harmonization. You're able to connect to everything. You're able to collect your data, but then you're ending up with a huge amount of only quantifiable terabytes that you cannot use because people are putting a lot more pressure on getting the data instead of getting information out of data. How do you see the future of harmonization?
You are spot on. So the question was, I'm going to try to summarize it, is that people do put a lot of emphasis on getting the data and not exposing the data within the right way. And you are completely right. Those are the principles that guided both core services architecture and the centralized platform. We were worried, like, how can we get the data? Like I said earlier, I have this 10 years of financial data. I use only the last 6 months. And nobody cared about that, because the business had no idea what happens behind the data, and the data had no idea what business wants out of them. And the future, I wouldn't even say it's not the future, it's the past. It's already started. Like, even ourselves as an architect, before when I was working in the field, I was going, yeah, great. You want to build this availability group failover cluster? I have my principal, I have my secondary, I have my replicant data center. I was so focused on the technical side, and I was not asking, what are we going to use this for? Like, what is the RTO? What is the RPO? Do you need that RTO or RPO? Sometimes I over-architectured things that they didn't need it because they didn't know what to ask. So they asked for the state-of-the-art, which is expensive, high maintenance, high risks, when they could have been good with a mirroring or a log shipping, to be honest. So you're right, and that started in the past, but we've shifted, and I think where we are trying to get is, let's first start with the problem that we are trying to address, and then jump into the solution. Because before we've had the solution, and we were starting from the solution, hoping that we are going to meet the problem in between. And that's exactly what we are trying to drive. Even within our architecture teams, we do have a lot of technical debt in our internal teams that we are inheriting right now because of this approach. Like, we build these amazing systems, don't talk to each other. We have this amazing data in all the places, but how does it address our problem? So that's why we say, let's go with a harmonized mesh for each domain. You are on the loan section. What would you like to fix here? What answers you need? Do you need to know the risk? How do you define the risk? What data you need for the risk? And data can be a combination of semi-structured and very well-defined schemas, like you would have for a user profile. Telemetry data, that's another goal. You need to understand your user profile. You need to understand the profile for somebody who clicks on a portal. Like, where are the places where people click? Are these the places where I want them to click? So you need to collect telemetry. Is telemetry structured data? Most of the cases it's not. It's just simple JSON. You are happy with the best you can get. Anything is better than nothing. So yeah, you're completely right. That's what we are trying to do, and that also starts with us. So in a harmonized data mesh, in the center, there is though something that's very important for all the domain. Regardless of the domain, you need to make sure that you have security, compliance, and tagging and discovery. So those were a lot of terms and principles that would apply to any technology, would apply even to a multi-cloud approach, regardless if you're going to use Databricks, or if you're going to use Synapse, or if you're going to use some Hadoop clusters for big data analytics. Those principles will not change. Now, in terms of technology, for the data governance, at least from the Azure part, from the Microsoft glass pane of this world, there are a lot of things that you can use. There is Purview and there is Synapse. In Purview, you have data asset lineage and classification and policies that you can define. We've always tried to curate data after we got the data. Well, the trend is changing. Now we define policies and make sure that we collect the right data in the right way. We are not always going and cleaning it and then try to extrapolate it, or no, quality is an input. There is a saying, if you have a good, that saying, I'm going to put it in a good word. If you have a good input, you have a good output as well. And that's very important when it comes to data. How do I make sure that the values that are put in there are not X's, or that those cells are not empty? Because guess what? You come with your machine learning. For example, I was building the SKU recommendation algorithm for relational databases, people who migrate from on-prem to Azure. And I was looking at performance counters in order to generate the right SKU from an algorithm perspective. The most difficult challenge was, let me get the data. Let's make sure I don't get empty values. Let's make sure I have the right granularity of data, because if I get CPU consumption once per day, it's not going to work. Make sure I don't affect the system that I'm collecting from. So there's a lot of questions that you need to have in mind when it comes to data quality. Not just curate it, but how do you proactively approach it? What do you do at data collection, at input, to make sure it's clean and to make sure it's accurate for what you are trying to achieve? Because maybe you are collecting the information about the weather, and you need geospatial information for detection of the location. And that can happen, and you can write an amazing application that does something else. So there's a lot of technical capabilities in Synapse space, in Azure SQL, Cosmos DB. Azure SQL comes with tons of flavor, from Azure DB to SQL MI to hyperscale SQL in a VM. There are a lot of technical choices out there. You remember the first slide. Tools are there. It's what are we going to do with the tools? What data does my work have that I can use? And that's the question that we should ask. And if you are lucky to have a data officer, What sensitive data does my organization have and who has to use it? And that's what you implement in the center, which is governance and security. That's common and it's a standard for all your domain, regardless of the technology that you use behind the scenes. So in Azure, first you have to define your data products, then analytic partners and architecture solution, and then governance. I would say 2 and 3 can be done in parallel, to be honest. You just have to put them, I just put them in order, but they can be done in parallel. So what do we have here? In the centralized solution architecture, all clouds, they offer the possibility to connect to other cloud as well as on-prem. That's the input. You have data factory, you have IoT Gov, you have connectors that can go through a data flow and land up in a data lake. And from here, depending on your domain, you can go through the discovery and onboarding through Synapse Analytics, or descriptive analytics with Power BI apps, SQL or Synapse, prescriptive analytics with ML or, of course, Kubernetes, and data share and Azure Data Factory for data exchange between multiple systems in terms of technology. How do I define the products? Well, I have based on the business needs and entities within my organization. That doesn't always align to teams. Those are not synonymous. I'm in the loan team or in the mortgage team. If you are in IT world, you are everywhere in most of the companies. So it can be customer interaction or investment or risk management. So that's the first step. I define my product. Second one is, what can I do it by banking zones? Can I have some product zones? Can I have the credit monitoring, risk management, and loan in the banking data product zone, and the next best offer, damaging claims and risk management in the insurance data product zone? What's common? Audit, discovery. Data governance is common, and it should be a standard between all the domains. In the analysis patterns and architecture solution, of course, this is a very simplistic way of, that's how I connect with the center, which is the governance, and that's the input and output that I'm expecting, which can come from another domain or can come from a monolith as well. It can be internal solution or external solution. How do I translate that diagram into technology? And here, remember my first slide where you have tons of options? Well, you have Synapse Analytics, you have Power BI, data lakes, tons of things that can cover the trends that I described earlier. And this can be different. For risk management, you most likely use machine learning algorithms. If not, even some may even go crazy with neural networks. I can bet you're going to use this. In the loan approval, you're going to consume the output of this as well. And it can be different technologies and different companies. In the data governance space, there is Purview as well. There's a huge investment from Microsoft on the Purview, and maybe we can talk about it, have a dedicated section in the future on how you can leverage that to discover, tag, asset, and classify your data estate, regardless if you use SQL or not. That's a great, amazing feature. Have a look if you haven't already. And then there is the physical layer. And I'm going to leave this here for you to study. Is how do it's a sort of a lower drill down, regardless of technology, on how do I approach the data sharding, how do I build my stores differently, how do I store my master data, because now we do have data asset and data catalogs, because we need to keep track of those 10 terabytes. I cannot just query every time to figure out or call my friend, hey, what's in that table, by the way? It says this data, can I delete that table? And you won't find the answers until you do it. So there are different interfaces. And there's a last thing that I wanted to touch is personas who are involved in this. You're not alone. And the roles is not just DBA or what did I hear? So I heard DBA, I heard database developer. Those are like the market standards. No. You need to have a data product engineer. If you don't have somebody dedicated, you need to sort of fill in for that role, to ask the right questions, what we are trying to do. And you will have the IT and business, if you can do it together, the data product and the data steward, that would be great. And you have to be aware about your data consumers and producers, both from the business side as well as from the technical side. And that's where the data sources and the drivers and connection strings and supported versions and everything else comes into place. Almost my last slide, I promise. Almost my last slide, but that's sort of a marriage of the principles and the technology in one single place. And you don't have to learn it by heart. You just have to understand how you can apply these principles within your organization. You don't need to know them all. You don't need to apply them all. You don't need to go just, oh, everything has to be a data mesh today. But think about your architectures and what you currently have and where it makes sense. A few code design principles. I'm pretty sure you're going to hear a lot about code designs today. These are mostly wisdoms from the data space, because we are a code space. And it's something that you may want to think about yourself as a data store. And one of the scenarios that I want to call out is, am I both a provider and a consumer? Think about the next step as well. There's a lot to discuss about data. We can sit here for years for sure. The takeaway from this session is for you to apply the same agile principles and the same microservices principle that you are considering for other applications within the data space as well, and to assure you that there are interconnected technologies that can help you do that. I'll be happy to take any questions. I'll be around. Just feel free to come to me and talk to me. I promise I'm not a scary person. I'm a very friendly person. And I'm looking forward to hear more about your scenarios. Thank you very much.
Thank you so much.